Hello and welcome to my YouTube channel. My name is Siobhan Richards. The last time here with C++, we stopped at these fundamental or primitive data types in C++. Now we have to move on to these reference types. So these reference types, they're typically made of the building blocks. They're made of the primitive types in C++. Okay. So under these user-defined or reference types, meaning the user defines these data types, and usually they're stored in memory as a memory address, so hence it's a reference type. Okay, so we have under these user-defined types, we have classes, structs, and enums. So only three, right? We also have arrays, but we could skip that for now. All right, so when we get to control structures, we could look at arrays. So let's look at the creating, declaring, and initializing. Right, so not initializing, but adding attributes and actions to these user-defined types. Okay, so let's get our online C++ compiler here. Okay. You could use this program is here. Okay. So again, it comes with this main.cpp, and we have our value returning function here, int main. So let's delete that. Okay. See if it runs. It runs. Okay. So let's get rid of that statement there. Okay. So the first reference type we have here is classes, right? So how do we declare a class in C++? Well, you need a class name. So class, okay, that's the keyword class. We covered keyword before. So class, let's call this and you want to keep it capital, first class here, okay, and you need this curly operator in C++. In addition, when you have more than one things inside your file, you need this semicolon here, okay. Okay, so now we need to determine whether we want to make variables public or private, which we'll look at again in object-oriented programming. But for now, we could just call this public keyword. Now we need to have attribute. So let's make this first class. Let me see. I'm just trying to think of like a classification of object. We used vehicle animals. Let's make this classification of cell phones. Okay, so just remember, class is like a classification of a certain thing. Okay, so cell phones, they have some model, right? You have this model name, and you could have maybe chip inside, right? So yeah, let's do that. So let's make the string model name. Oh, let's do model name and model number. So std package string, and we'll make this model name. Okay. We could have some default values here, and let's call this model name Apple. Okay, Apple phone. Okay. And let's have some model ID. Okay, so int model ID. Set that to 1, 2, 3. Okay. So just remember, this string here is from the standard library, okay? Because we didn't use the namespace. So let's run, no problems. That class was created successfully. We could have a constructor here to construct objects of this class. But for now, let's just keep it without a constructor, okay? Okay, so let's now make a variable of this class. Okay, so to make an object of this class, we'll need the class name, because classes are like you're creating your own data types. So to do that, we'll need my first class, and then you name this. Let's call this phone 1. Right, so phone 1. Okay. All right. So let's run. No problems there. So we have this my first class phone 1. Okay, let's see. We may want to access these values here. So let's do a standard out, cout, okay. And let's do phone one dot notation, okay, model name. Okay, that will return phone one. Let's add some space here. And then add phone one dot model ID. Okay. So now we have our model name and model ID. Okay. That's it, right? So that's a basic class. This is like a static. I call it static, right? Static object class, right? Or a data class. It doesn't have any actions, right? So it only has some data. What if we need to update values inside this class? If we need to update values, we'll call the class name, okay, phone one dot name, and we rename the name. So for one, model name here, okay, model name, and we'll rename this, okay. Let's rename it to Samsung, okay. So Samsung, okay. And let's change. We could change the ID as well. So phone one dot model ID equals 245. Okay. So that's a new ID, and then we could call our print statement here and see if it updates. Right. So again, these classes are reference, right? Reference base. Okay. So we have that Samsung here. Let me put a space here. Backslash n here. Okay. Okay. So we had the same class, right? So we made a class phone one. No constructor needed here. Again, it's just a data class, right? So no constructor. So we have this phone one object, right? And then we have the name, model ID. We update that object, and now this is the new name and model ID. So that's classes, okay? So classes, and then you have structs, okay? So just remember, classes and structs are kind of the same, but with structs, there's no public access, right? No, there's public access on the structs, right? So it's always public access on for the struct, while for the class, you could change access there, okay? So kind of like the same, but structure is typically used for like records, okay? Okay, so let's make our another or second user defined, and it's a struct. So let's name this my first struct. We need a curly brace, right? So it's kind of similar to Java. And then it's always public, right? So now we could do public keyword here, public access here. And then std, and for the struct, let's make this a collection of students. Okay, so let's make string student name. Okay, we could set it to some default value. Let's call this Bert or something. Okay. And then the next one, we could call it int student ID, okay? And then set that to 1, 2, 3, 3, okay? Structs, you could have constructors for the struct as well, but in this case, let's just keep it as is. Can we have an array in the struct? Yes, we could have an array in the struct. Let's say I need an array here. Let's do int my array. But we'll look at array later in let's do 1. Sorry. Okay. Okay. Let's run here. Oh, we need a semicolon here. Okay. int y array, flexible array, initializer. Okay, so you have to tell it the number of values, 3 values there. Okay, so in C++, you have to tell the array the number of values you need. Okay, so if I need to access that array from the struct, first I need to create the struct object. All right, so let's do my first struct, my, and call it we said student, right? So let's call this a student1 object. Okay, and then for this object here, let me have some more space here. Student1, right, dot my array. And to access a value from that, we have to use the array accessor, okay, and then access the first value, okay, and it'll access 1, 2, 3. Okay, but for this one, we could store it in a preliminary variable, but we could just print out, right? So std cout. Okay. Okay, so we could see out the array variable from this my struct here. Okay, so let's have a end line here. So we have this new my struct to show us how to create the struct. Similar approach, right? Because these reference types are similar to data types. All right, so this file has one class here, one struct here. All right, so we declare a class name and so on. So let's do that. Right, so it returns 1. Right, so let's change these default values to maybe 120. Returns 120. Okay, so that's how you access if you have an array inside your struct. Can I have a struct inside my struct? Yeah, probably, right? So you could nest these as much as you want, just like in Python where you have dictionaries and dictionaries, right? It's just an easier syntax, but you can have those, okay? All right, so we looked at structs, right? So structs are usually records, right? So these are usually the data type that you use that are static, right? And classes is usually attributes and actions, okay? So our last data type here is our last user-defined data type is the enum. So we call enum. Let's make this let's an example here. I did book category already. Let's do school, right? School level or something, right? So class grade. Okay. So for class grade, you could have elementary, elementary. All right. You could actually even set these to some values, right? So you could set these to values in C++. So elementary school, let's say it's up to 6 years old or something. Okay, set that. Let's say you also have so you have elementary, you have middle school. I'm not sure. Maybe it's what, 12 years old. I don't know. Right. So, oh, we need comma, by the way, to separate these. Okay. So it's a collection of static or collection of constants, and then college. Let's make this 18. Okay. So we're tying these constants to some ages, right? So constants being tied to the different ages here. Okay. Run that on, oh, not a comma, not semicolon here, comma. All right, so it stores the value. Let's make our first enum here, right? So to create our enum, we call our enum type class grade, okay? And let's call this let's call this we could do person again. Let's call this child1. Okay, so this is a child, and based on, you know, what age that object child is, we'll know whether their element. Well, based on their grade level, we'll know their age. Okay, so we could say std cout child1. And for enums, usually you don't need a constructor. Okay, these are just constants. So child1 dot elementary. Okay, child1 dot elementary. Okay. Okay, so that's this one here. Okay, what's going on there? So child1, which is none. So we have class grade child1. So child1 dot elementary here, class grade child1, which is of non-class type, request for member elementary in child1. Okay, I see there. So we would have to call it well, child1 equal. So for this one, you can't call it as a class. So child1 equal elementary. Okay. Okay. So now for this enum here, if we call the child1, it'll return the age. Okay. Okay. So this is here, it says you're requesting for a member. Okay, in child1. But this is not a class type, right? So this is not a class type. It's a collection of constants. So you have to call basically the variable, the data type, right, or your user defined type, child1. And if you set that child to elementary, that means that child contains the value 6. Okay, and there it is. Okay, so we work through that error as well. Okay, so those are the three main reference types in C++. We've looked at declaring and adding attributes, right, for all these three data types, and how to access the values in these data types. And again, these are building blocks for more complex code. Okay, so once you understand these user-defined types, you could use these user-defined types to make complex data structures. Okay. And you need those data structures to be tailored to the data that you're trying to collect, right? So that your machine could process the data as efficiently as possible. The next topic we'll look at is typecasting in C++. So how do we move from one type to the other type? Okay. And then after that, we'll look at operators in C++. Thank you again for watching. All right. See you soon. All right.